Or I take a vector space and take another vector space. I want to relate these two vector spaces. Transform one vector from this vector space to that vector space. So, we generally define what is called a linear transformation. What's a linear transformation? Let V be a vector space of dimension n and U be a vector space of dimension m. Then linear transformation is a mapping T from, let's say, U to V. That means a vector in U will be mapped onto a vector in V. A vector in U is mapped onto a vector in V. Suppose if I choose one basis in U and another basis in V, I can talk about what will be this T. That means I am going to have a T and the input for this T is U. That means some vector with M components, xm, and then the result is going to be y1, y2, etc. yn. Now you may realize that this T in general has to be some kind of a rectangular array of numbers. The components of T is called a matrix. It's a rectangular matrix. How many rows should be there? What should be the size of T? If this multiplication has to be making sense, this is an m by 1 matrix. So this should be m by n. So T has to be, in this case, T has to be an n by m matrix. There should be n rows and n columns. Let me define a simple linear transformation like this. Let T be a linear transformation. This is just an example. Let T be a linear transformation from R2 to R3. R2 is the plane, R3 is the space. So every point in the space, let me define onto a plane. Every point in the plane I define into a space. So let me define in this particular example that T acting on xy is equal to x plus y, x minus y, x plus 2y. Let me write a linear transformation like this. Now tell me what should be this matrix T. If this is the linear transformation, what should be matrix T? What should be the size of the matrix? Is it 2 by 3 or 3 by 2? 3 by 2. 3 rows, 2 columns. And what is that matrix? T is equal to, I should write 3 rows and 2 columns. 1. What is the first row? 1, 1. 1, 1. Second corresponding to every linear transformation, you can define 4 vector spaces. Pertinent to this linear transformation, any linear transformation you have, you can define 4 vector spaces. I will define them here. Let that example be there. Let's say we have an n by n matrix. So, let me write this example later. So